Hi everyone, my name is Olivia Daniels and this is a short presentation on the regulation of pH within our blood. Now, our blood has a very specific or a very narrow range. It ranges between 7.35 to 7.45 pH. Now, if the pH drops either below that or above that, then we suffer from acidosis or alkalosis. Now, the reason why it has to be that tight range is things like proteins. They tend to denature if the pH is either too low or too high, and if that happens, then basically they change shape. They won't be able to fit into their binding sites and they won't be able to function properly. Now, I'm hoping that everybody remembers basic chemistry, and the pH is the negative log of the hydrogen ion concentration. So we're looking at the amount or the concentration of hydrogen in our blood. Now, if we have high hydrogen concentrations in our blood, excuse me, just technical issues here. If we have high hydrogen concentrations in our blood, it means we're going to have a low pH and we are going to be suffering from acidosis. Whereas at the other end of that scale, remember the pH scale is between 0 and 14. 14 means there is a lot less hydrogen, so there's a lot of hydroxide. Hydroxide here, which means the pH is going to be right up there, and we call that either basic or alkaline. In the middle, that's pH neutral, which is pH of 7, and we're looking at pure water there. And you can see my two little lines here, that indicates roughly where the body pH is going to be, and you can see that it is slightly alkaline or slightly basic. Now, the way we control that, or the way our bodies keep that within that range, is through two processes, either through the metabolism or through the respiratory system. Now, with the respiratory system, what happens there is carbon dioxide, well, that one's directly linked to hydrogen, so the more carbon dioxide you have in your system, the more hydrogen you're going to have in your blood. And carbon dioxide, as we all know, is something that we breathe out. So if we're not breathing out enough carbon dioxide, that can lead to respiratory acidosis. Whereas on the other hand, if we're breathing out far too much carbon dioxide, we're not retaining enough hydrogen, and that can lead to respiratory alkalosis. And we can actually our bodies can actually compensate. So if we're suffering from respiratory acidosis, all we have to do is make sure that we're expelling more carbon dioxide to balance that out, and vice versa. If we're suffering from respiratory alkalosis, what we can do is maybe not breathe out so much carbon dioxide, and that'll bring that hydrogen concentration up a bit, which means it'll bring the pH down. Now, another way our body compensates or brings that pH control altogether to make sure our blood stays within that range is through metabolic processes, particularly the kidney. Now, with the kidneys, what they do is they reabsorb bicarbonate or hydrogen, and that regulates the amount of hydrogen or bicarbonate in our systems, and that regulates the pH. Now, this is a slower process, so respiration is certainly a quick process, whereas the kidneys, they work a lot slower. But nonetheless, one compensates for the other. So if you're having respiratory problems, you might be suffering from acidosis or respiratory acidosis and alkalosis or alkalosis. And our kidneys can kick in and try and regulate that pH. Whereas if our metabolism is suffering from metabolic acidosis or alkalosis, our respiratory system can kick in and balance that out. Now, a couple of causes of metabolic acidosis and alkalosis is, metabolic acidosis is caused by diarrhea. So basically, things that we eat, they go through our stomach and they pass through our small intestines, and our pancreas creates bicarbonate, and that gets absorbed into the small intestines, and our small intestines reabsorb that bicarbonate into our blood. So when things are passing too quickly, that bicarbonate can't reabsorb back into our blood, and we suffer from metabolic acidosis. Now, on the other end of things, literally, vomiting, we're emptying out the contents of our stomach, and our stomach's very acidic, and if we're getting rid of all of that, well, then the pH in our blood tends to rise because of the lack of hydrogen, so we end up with metabolic alkalosis. And that's, as I said, if we're suffering from metabolic alkalosis or metabolic acidosis, our respiratory system can kick in, and if we regulate our breathing, we can, kind of control that to a degree. And that ends my presentation. I hope you have enjoyed, and thank you very much for watching.